Hello everyone, my name is Imduaikiat, and I am going to demonstrate how the uniform circular motion works. Firstly, a circular motion is a motion of an object in a circle moving in a constant velocity, and this is the uniform circular motion diagram of a small object moving in a circle. The circular motion has four main qualities: position, time, velocity, and acceleration. Position is the most obvious quality because it helps describe its circular path. As for velocity, it describes how fast the object is moving and in what direction. And for its direction, in the circular motion, it is not along the path of the circle. As you can see here, its direction is perpendicular to the radius of the circle, otherwise known as tangential velocity. The velocity direction is constantly changing because it's moving in a circular motion. To prove that velocity is tangent to the circle, we will use a ball attached to a string. So we spin the ball in a circular motion parallel to the ground, and when the ball reaches its maximum distance from the center, we let go. As we all saw that, it is proof that the velocity is tangent to the circle. Why is it that the velocity is tangent to the circle? The answer is because of the first Newton's law of motion. The law states that every object remains in motion for as long as no forces act on it, aka law of inertia. This helps explain so that the object will move in a straight line for as long as no forces disturbs it. We could calculate its velocity by using this formula. Velocity equals to 2 pi radius, the circumference of the circle, times the frequency, or 2 pi radius over time. These two formulas are equal because frequency is equal to 1 over time or period t. Therefore, we could substitute it into the formula and we'll get the same results. The next topic is acceleration. What exactly is keeping the ball moving in a circle, constantly changing its velocity direction? The answer is the centripetal force, the reason why anything moves in a circle. It is also because of that force that causes an acceleration towards the center of the circular motion, called centripetal acceleration. This explains how the velocity is changing since you are pulling the object toward the center. However, there is some confusion about the force. Some might ask, when we're in the car, then the car turns sharply. You will feel a strong force pushing you against the door when you're doing a 90-degree turn. Why does it feel like it's pulling us away from the center instead of pulling us towards the center? People call this centrifugal force, the opposite of centripetal force. However, this force does not exist. Looking outside the perspective, when the car turns, it forces the passenger to move in a circle, and the door is there to keep them turning, pushing them towards the center. This is because of the centripetal force. However, what the passenger felt was different since they felt like they're being forced against the door, as if there's a centrifugal force pushing them. In spite of that, there's actually nothing to create such a force, making it a misconception. This occurs because of Newton's third law, since the force the door was making against the passenger exerts the same force against the door. The formula to find the centripetal acceleration is velocity squared over the radius of the circular motion. By finding that formula, you can find the net force using centripetal acceleration. Force is equal to mass times acceleration, so you can substitute the formula of centripetal acceleration into the equation and get force equals to mass times velocity squared divided by radius. What we did earlier was the horizontal circular motion. Now we will discuss about the vertical circular motion. So imagine spinning a yo-yo around at its highest point. This is where we want to solve the tension of the string. We learned earlier that the centripetal acceleration is equal to velocity squared over radius. The weight of the yo-yo is mass times gravity, which always points downward. Because of the additional force added to the centripetal force, the new tension would be acceleration equals to net force over mass. Net force is converted to weight plus the tension, and acceleration is also converted into as velocity squared over radius. Therefore, we found the tension of the string equals to mass times velocity squared over radius minus the weight. Because this is the tension of the yo-yo at its highest point, the yo-yo's tension at its lowest point would be mass times velocity squared over radius plus the weight. In conclusion, we learned that in a circular motion, the velocity direction is tangential to the circle and its acceleration points toward the center of the circle. Then we learned about the difference between the centripetal force and the centrifugal force, whereas the centrifugal force does not exist. The formula of velocity and centripetal acceleration, and the concept of vertical circular motion. Thank you for watching my video. I hope that this video helps explain and helps you understand more about uniform circular motion. Thank you for watching, and please share it and like the video.